Okay, the table shows lifetime peptic ulcer rates per 100 population for various family incomes as reported by the National Health Interview Survey. Here is the income and here's the ulcer rate column. So what we're going to do is we're going to create a table, and we can do that in Desmos. So we can go here and then put in a table, and then we're going to put in our particular values for that column. So we have 4,000, and then 6,000, 8,000, 12, 10,000, that should be 12,000, and then 16,000, and then I'm going to go ahead and fill in the rest. Okay, then now that I've filled this out, now I want to be able to then look at what the dimensions should look like. So we want to put in our rectangles here. So for our x values, we're going from 4,000 to 60,000. So we can start at 0 and then go to 61,000. And then for our y, we can start at 0, and it's going to go all the way up to, let's say, 15. And so therefore, that's what our graph should look like. I'm going to zoom in just a little more so we can kind of copy that into our document here. So now that we've created a scatter plot, now we want to ask ourselves, decide whether a linear model is appropriate, and the answer is yes. So a linear model is appropriate for our data. Now the next question, part B, is asking us to find and graph a linear model using the first and last data points. So the first data points is 4,000 and then 14.1, and the last data points is 60,000 and 8.2. So first thing we need to do is we need to find the slope of those 2 points. So the slope is going to be 8.2 minus 14.1 divided by 60,000 minus 4,000. So therefore, that gives us approximately negative 0.000105,357. So therefore, there is our slope. And now we can use the point slope form. So point slope form, y minus y1, which is 14.1, which is equal to the slope, negative 0.000105,357 times x minus 4,000. And so distributing the negative 0.00105357 to those terms, and then adding 14.1 to both sides, we get y, which is equal to negative 0.000105,357x, and then plus we get 14.521429. So now we want to find, and we're going to graph this linear model using the first and last data. So now that we already have this into our Desmos calculator, let's go ahead and put in this equation. So negative 0.000105,357 105,357x plus 14.521429. Okay, so now we can see what this line looks like when we put it through our graph. Now, this was the line when we choose our first and last data points. Now, this doesn't represent the line of best fit. In order for us to do that, we need to use the regression equation for that. So, we will see that in the next part. So now in part C, it's asking us to find and graph the least squares regression line. So, let's go back to Desmos. Okay. And then we're going to go ahead and put in the regression line. So I'm going to go ahead and paste our formula in there. And you can see that is the blue line that's going through here. And so that regression line is the following. So we have, this is the slope and that is the y-intercept. So let me go ahead and copy that information. Bring that in here. So there's our slope and there's our y-intercept. So we can say that the least squares regression line is going to be y, which is equal to negative 0.0000997855x plus 13.9508. Okay, and then when we graph that, we saw what the graph looked like. So if we eliminate the first line here, then we can see what this looks like. And so this goes right through the middle of the data, which is why it's called the regression line. So therefore, there is our graph with the regression line. Now the next question says to use the linear model in part C to estimate the Ulcer rate for an income of $25,000. So let's go ahead and put that in there. So we want here, let's see here, since that's in the middle, and that represents 25,000, so I'm approximating here. So if we hit that line, and then from here, we get to this line here, where do we actually hit? Well, what that means is that when x is 25,000, then the y value is approximately 11.456, or about 11.5 per 100 population. So what we can do is we can also use this model, y, which is equal to negative 0.0000997855, multiply that by 25,000. And then add 13.9508, which gives us approximately, again, 11.456, which we can round to 11.5. Next question says, according to the model, how likely is someone with an income of 80,000 to suffer from peptic ulcers? So that means that this becomes y, which is equal to negative 0.0000997855 times 80,000. plus 13.9508, which is approximately 5.968. So therefore, we can say that when x is equal to 80,000, y is approximately 5.96, or about a 6% chance. And the last question here says, do you think it would be reasonable to apply the model to someone with an income of 200,000? So that means we would take y, which is equal to negative 0.000997855, multiply that by 200,000, at 13.9508, and then what do we get? Well, we get approximately negative 6.0063. So what does that tell us? Well, that tells us that when x is 200,000, y is negative. So the model would not apply in that scenario.